Welcome back, everybody. This is Eric and Chad here with Iraq Veteran 8888, and we're going to be posing the question today, what type of thread locking compound should you use on your firearm? We're going to go over some different options here for you. We did our top 10 tips for the home gunsmith recently, and that was one question that we got quite a bit, was a request for us to go into a little bit more detail on that subject. So here we are, and we are certainly going to get into it. I would like to thank our friends at Sonoran Desert Institute for supporting our videos. If you're looking for a career in gunsmithing technology, they definitely have all the knowledge right there at your fingertips that you need to get into your career. They have wonderful instructors, great programs. They even have a drone program, which is epic. People are learning how to fly drones. They're being used in so many different programs now. So check them out, Sonoran Desert Institute. They also have some really nice reloading programs as well. So, tell them we sent you, and a big thanks to SDI for supporting our efforts here on the channel. All right, so people get into trouble, Chad, with thread locking compounds. We're going to kind of break into it and try to keep this as basic as possible, and maybe also share some interesting stories, some horror stories that we've seen over the years of situations where maybe someone's used a little bit too much Rocksett.
Keyword is try. You guys know that. We never can stay on topic in all these videos.
Well, we're always going to go off the beaten path a little bit.
Oh, yeah.
Oh, and it's also worth noting before we get started. All right, show them the goods.
Hallelujah.
Turn your head, show them.
Back.
It's all gone.
It's all out of here. It's in a bag being shipped out to Wigs for Kids right now.
So, all you people that were giving Chad a hard time about his hair, all right, fine. You got your way.
Don't worry.
Cut his dang hair.
Hey, look, all those videos are still out there, so I'm sure there'll still be plenty of you need to cut your hair comments, even though my hair's gone. Out of here. See you later. Bye.
You look younger.
I heard that a lot. So,
yep. Yeah. You got a little gray in there, though.
Oh, yeah. The gray
getting the gray wolf syndrome going on.
Oh, there's going to be more of that. My kids are growing up, and yeah.
All right, so thread locking compounds. Right. What's the skinny? I mean, so you guys have gotten screws before that come pre-treated with thread locking compound. You see like the little blue blob, or sometimes it'll be like a white-looking blob that's on the end of the screw, and it's like dried up thread compound that they'll put on there. That's what that is. It's a thread locking compound. So why do we use them on modern guns so much?
Just to clarify, sometimes the screws that you get, like, for example, with Magpul factory M-Lock hardware, it'll have like that kind of whitish, off-white compound. It's actually not really like a thread locker. They consider it more of an anti-vibration coating. So it does the same thing, but like specifically it's just to keep the screw from backing out under vibrations more than anything else.
I have seen some screws that ship with like blue globs on the end of them.
Yeah, that's like these here. That's more like a thread locker, but like that kind of pasty stuff is an anti-vibration compound in the technical sense of things.
Interesting. I didn't know that.
Yeah, I didn't know it either. Not until recently, but like we've always talked about using blue Loctite, right? Everybody uses blue Loctite, and then people use red Loctite. And a lot of folks don't know the difference. And we remember that from working at Moss, trying to get parts off of guns. Like, what in the hell did you do to this thing?
It does work.
You got to you usually have to take heat to, say, like a muzzle device that somebody like wrenched on there, right? And you take heat because you've got a mystery thread locking compound on there, and put a torch on it. And if it starts smoking after 30, 45 seconds or so, it's probably got some Loctite in there, and you're burning it off. All right, so thread locking compound for like firearms applications is really not that great for high heat areas, right? I mean, for scope mounts, rings, things like that, you can put a tiny amount of blue Loctite on there, and it'll just help keep the screw in place and sometimes torque properly. But you have to be careful with torque specs because some manufacturers will specify torque for dry screws, okay? Not put anything wet on there, because if you do that, you're changing the torque specifications and you may not be getting the proper torque, and then you're running into problems. Variables. I hate variables.
That's true. I've always been the kind of guy that I wrench my, scope mount screws down with Rocksett because I don't want them to move again. But am I probably not supposed to do that? Yeah, I'm probably not supposed to do it, but I've always done that, and I've never had them walk back out. Rocksett is some pretty stout stuff. I mean, proceed with caution. And I know one horror story of when I was still working at Moss, Ray and I had an AR come in that the gentleman couldn't get the muzzle device off. And we were thinking, all right, Rocksett maybe? You know, first we tried heat, wouldn't move. Then we tried ice water with the Rocksett because you have to use cold water to get Rocksett loose. Wouldn't come loose, and we're thinking, what in the world is going on here? Something going on. Well, the guy had tried to torque on it so much that, you know, the pin that aligns the barrel extension in your AR in the receiver, that the barrel extension, not the receiver, but the actual pin that goes into the receiver. When you look in the front of an AR receiver and there's that little slot and that pin slides in, he went to torquing on it and sheared that pin. He put the brakes on it so hard. And it turns out that he used green sleeve retaining compound to put the muzzle device on. And it did not move.
Yeah, but so
it's like welding it.
You know the funny story about that? That didn't happen to Moss. That's me. Most likely. Unless there's somebody else that's as dumb as I was.
We had one come in Moss that was like that.
Really? Yeah, I put green sleeve retaining compound on a 14.5-inch barrel that had a muzzle device spin off. Like it was pin and welded. And I'm like, well, I'll just put green sleeve retaining compound on it for now, and I'll just repin and weld it. And I decided, you know what, I'm going to try to get this thing off of here and do something with the barrel. I spun the barrel out of the receiver extension. So that pin is what they consider an alignment pin. So they'll thread the extension on, right, and they'll drill it out, hard pin it in place, and then they'll cut the gas port in alignment with that pin. So it's an alignment method, you know, and keeps the barrel from rotating off of the extension.
It sheared it.
It did. It sheared it right off.
That happened to me and Ray.
So we'll talk about green sleeve retaining compound in a minute. But like commonly, like you see blue and red Loctite. So blue is like a low temperature, low strength Loctite, and the big thing with it is once you torque it down in place, you can pretty easily break that contact and get that screw out of there without any undue force.
So probably scope rings, mounts.
Like anything that doesn't have any sort of heat affecting it or anything like that, but like and low torque too. I mean, for the most part, we're talking like 15,
a trigger adjustment set screw or something.
If you just want to keep that in place, the blue Loctite's perfect for that application. Really, like red Loctite, as far as fasteners go, I've just kind of stopped even using it on firearms because it does require heat in some cases to get it breaking loose, because you really have to like break the compound down in order for it to loosen up and be able to untorque it and everything.
I guess it depends on how permanent you want it.
It does.
And,
I mean,
you know, if you ever want to change it.
Yeah, this is a semi-permanent application, okay? And a lot of guys will use either red or blue Loctite up under, say, a scope base that goes on to like a Remington 700 receiver. You know, it's curved, and the scope base is curved as well, and it kind of helps fill in the gap and keep it in place a little bit better.
I've done that before.
I've done it too, and it works with blue or red. Either way, it doesn't matter.
I've done it with red.
But you get into the green sleeve retaining compound, and it's called sleeve retaining compound because it's meant to retain two components without threads. That's why...
Used in the automotive industry.
Yeah, so like the old saying goes, if you have a two-piece mount or a two-piece component and you want it to be a one-piece component, you use green sleeve retaining compound. So
this stuff is no joke.
If you want it to be permanent on your firearm, use that. If you don't want it to be permanent on your firearm, stay away, please, and thank you. But
some would say that Rocksett is semi-permanent, because I think the misconception that people heat it up and they think, okay, we're always taught that, hey, if something's stuck, apply a little heat and give it some force, you know, and let the heat work. But I think most people just don't understand that with Rocksett, it requires cold and not heat.
It technically, I used to think also that cold water works best, and in my experience, it still does work best with cold water.
It seems to work well when we dip it in cold water, like a muzzle device.
It is technically water soluble, so really any temperature water should work. But Rocksett excels at repelling heat. That's why it's used for suppressor mounts and things like that. It's because it'll basically glue your muzzle device on until you want it off, more or less. And I've had some experience with Rocksett where guys have basically taken the bottle and opened the lid and dipped their muzzle in there and then proceeded to pour it into the muzzle device and then screw it on with
Yeah.
it squeezing out.
You don't need a lot. It doesn't take much.
Yeah, like literally with any of these thread locking compounds, especially on like a muzzle device, you need a drop, and that's it. One drop between the two.
Another very important thing as well. You want to make sure that your threads are clean.
Oh, yeah,
right?
absolutely.
Don't have a whole bunch of carbon or especially grease or oil. Anything like that is definitely going to, it's going to mess with the adhesion of the thread locking compound. And I know that there's been many of you that have taken a muzzle device off of a gun that maybe you've put a few thousand rounds through, and you think, oh, I bought a suppressor and I'm going to put a suppressor muzzle device on this thing and whatever, run my can or whatever you're going to do. And I know you're out there. I know that you've taken your factory muzzle device off, and then you look and you see that puck of carbon built up around the crown. And I know a lot of people are tempted to go, just put the new device on there and roll with it. You want to take that opportunity while you've got that device off to get that crown nice and clean, because that can affect accuracy. As those gases expand around the muzzle, you want a nice, like, sharp edge for those gases to go out against, because it can, in some minuscule little ways, you do get some additional variables added on to the mix a little bit when those gases are expanding erratically or in random directions, or you begin to get, like I know you've seen with cast bullets, like a lube star on the end of the barrel, right, where you get that lubricant and it looks like a star. That's why they call it a lube star. But with a lot of like semi-auto use and a lot of heat, and you get a lot of carbon and fouling and stuff, it begins to form this like black puck. And I've always generally tried to, you want to keep that as clean as you can too. So just a little maintenance thing to kind of add to the original context of the top 10 tips video. Clean your muzzle while you've got your muzzle device off and get those threads dry and clean. And we usually just use like a little steel brush or phosphor bronze brush and get those threads nice and clean, grab some patches, wipe it dry. You could even use a bit of solvent or something if you want. That probably helps if it's real stubborn dirt that's on those threads.
I was going to say a little bit of degreaser helps. Just make sure that those surfaces are prepped and ready to receive a thread locking compound or an anti-vibration compound. Otherwise, it's almost like it's like if you took your car to get painted and they didn't wash your car before they started painting it, right, and prepped it. I mean, 99% of the work that's being done, or like the final product, is in the prep work. So
that's a good way to put it. It is like prepping for paint in a way.
Yeah.
You wouldn't just paint over some old yard furniture that had crap falling off of it and expect the paint to look good. It's got to have a good surface to adhere to.
It does. All right, so just to kind of recap, so like blue Loctite for non-heat applications, ring screws, scope bases, things like that, where you want a little bit of that anti-vibration tendency
trigger
on there.
Adjustment screws,
stuff like that.
Anything that doesn't get hot.
I will say though, if the instructions in your particular item call for torque specifications dry, just go with that. As long as you properly torque those screws down, you'll be just fine, and they're designed not to come out at that torque. So they've done rigorous testing.
I want to add something to that real quick. You made me think about. I know y'all have seen situations where there might be an adjustment, especially for like a trigger, okay, an AR trigger, where maybe it's got some adjustability for take up over travel, something like that. And you'll notice that they'll have these little screws that have these little nylon tits on the bottom. And those nylon tits are designed to actually come to a little bit of it does come to a stop, but it might have a thou or two, like a little bit of play, right? So that it's not quite such a hard stop. It kind of gives it a slight amount of flexibility. So if you have screws like that, where it's a bottoming screw that has, like a nylon tit on it, obviously that screw is designed to bear a little bit of a load by design. So that in that situation, like Chad said, you probably wouldn't want to bother with the thread locking compound for that.
You're talking about like drop-in triggers that are one piece. So the reason for those screws is to put pressure up against the trigger and hammer pins to retain the trigger assembly itself in place.
Well, I wonder if a little drop of compound wouldn't hurt on that.
Most of the time, if you just torque them a bit, they'd be fine. But it really depends on the trigger itself, because some of them you may not be able to remove those screws because they might have an interface with another component in there, like holding a detent and spring in place or something.
We're probably splitting hairs at this point.
Yeah.
But these are the things you have to consider. Anything that is a screw that can walk out or something, It's just kind of, I guess, a point to consider.
Red Loctite, like I've used it before on higher heat areas, like gas blocks. So the set screws on a gas block, I've used Red Loctite on there. But since, I don't know, several years, I've used Rocksett pretty much on all those components because it does hold up to the heat a lot better. So literally just a tiny, tiny amount goes a long, long way. Now, talking about areas where you would want to use thread locking compound, all right, what are some places where you would not want to use thread locking compound and maybe something else like anti-seize?
I would say probably a situation. In fact, I was actually going to mention that on the Sega 12, for instance, right, the gas adjustment on the Sega 12, especially if you use a TAC 47 auto plug, I totally put grease on those threads because I don't want them to get seized up with a whole bunch of carbon and then fail to move. So like maybe a suppressor adjustment on a gas block or any type of adjustment that you do want to periodically turn here and there or maybe pull apart for cleaning. I would say some grease would be good to keep that moving. You don't want that to seize up. So there are some areas like on an FAL, that plug on the end of an FAL or even a SCAR, you probably want to grease that up.
So anything with threads, anything with threads, even like coarse threads or especially fine threads that are exposed to like high pressure, high heat, carbon deposits, things like that. Anything where you've got gas plugs that have fine threads on them, like M1As come to mind. The gas plug on the front, and Garands, anything like that.
Definitely the M1 Garand.
So it just helps in the future to be able to pull that stuff off of there and not have to worry about wrenching it off and breaking pins and stuff like that. Because once you get carbon lock on components like that, it's very difficult to get it out without a lot of patience. Maybe running the whole component in like a ultrasonic for an hour or so, and whatever the case might be, if it can stand it, with the finish. But
in the original top 10 tips video, we did mention how useful ultrasonics are. And that is one more case for ultrasonics. Sometimes you run into something that's going to be super stuck, and it is nice to kind of give it a little bath and take some of the grunt work out of it.
One specific part that I always recommend to people to put anti-seize on is like the superlative gas blocks. They're very unique. They have this little tiny adjustment plug, right? And it has these teeny tiny little fine threads on it. And it's not long. The threads are like 1/100 of an inch. Right, or 100th thou, and people like seize those things up all the time. I'm like, just take anti-seize and just goop it on there and let the excess blow out when you first shoot the gun, and I promise you'll be able to adjust it. You just give it a little turn, and it'll kind of break it loose, and then you can roll it right out. But anti-seize is also used when connecting two components that are made from dissimilar metals. Like, for example, if you've got an aluminum barrel nut or something, or a titanium barrel nut, a steel barrel nut, and you're connecting it to a titanium or a magnesium alloy or an aluminum receiver, right, on an AR. So wherever you're connecting two dissimilar metals, use anti-seize, and depending on the coatings and stuff, you could get like oxidation on those components that could lead to like deposits forming in those threads, makes it more difficult to get off over time. Most of the time you have to worry about it, but a little anti-seize or even like rig grease, we've used that a lot before, even some heavy grease, just something to grease those threads and keep those metals from purely contacting each other helps out a lot, especially when you want to change it out down the line. It makes it a lot easier to pull it apart.
Yeah, that is true. One thing that I wanted to, kind of mention there too with anti-seize and things like that too. So I believe the company is Loctite that makes those Loctite components. And if I'm not mistaken...
Henkel, maybe?
Okay. If I'm not mistaken, that same company also makes the copper anti-seize. I think it's called C5 anti-seize. Let's see. I was thinking of the term galvanic corrosion, but that's not the correct term. Although, let's see. Corrosion on an iron nail wrapped in bright copper wire showing cathodic protection of copper. This is some pretty nerdy stuff, but when you have two dissimilar metals, it can cause corrosion.
Yeah, I think it is like galvanic corrosion. Yeah. It happens on boats a lot with there's a term that they use.
Those anodes that they use the sacrificial anodes to help draw. It's like to keep it has something to do with the grounding of the motor in the water, of the salt
there's
water.
That, but also like the screws and stuff. They'll be what's called passivated, I think. So
Yeah.
they'll have like a passive coating that keeps the metal from directly contacting the other metal in that case. So
A boat anode purpose is to protect areas of the bottom of the boat from corrosion. Galvanic corrosion occurs when two dissimilar metals are immersed in a conductive solution and are electrically connected. We recommend replacing anodes when they are half eroded or dissolved, which is typically around a year.
is it
So
like
it's a
literally-
sacrificial.
Does it like literally electrify the bottom of the boat?
I reckon.
And
It
that
does.
salt water, you know?
It does.
But anyways, that's pretty much like all there is. I mean, there's multiple other types of Loctite and stuff out there and other thread locking compounds, but like these are really the most common that are used on firearms. But honestly, for pretty much everything out there, I'll either use blue or Rocksett now, and that's pretty much about it. Like, and look, a bottle of this stuff will last you forever.
I
Literally.
think with Rocksett being around now, it does kind of make the red Loctite maybe a little bit, maybe skip over the red Loctite, get some blue and Rocksett. I agree. I do find myself using quite a bit of blue. One thing I'll mention as well, just quickly before we go, I think this pretty much covers this video in a nutshell, but also shake the bottle up really well. Okay, you want to definitely make sure that that it's mixed up really well, because it's almost like if you ever take your sour cream and you don't shake it up real good, and then you try to get some sour cream out and you get that kind of fallout in there. It's the same thing. That these thread locking compounds will do the same thing. They'll kind of settle. So you want to shake it up really well, and also it doesn't take much. Like if you think it's going to be too much, it's too much. Like tiny little amount. That bottle that he's got on the table right there, it should last you well over a year, if not a couple of years.
So I don't know if you guys have ever seen it.
You'll waste more of it than winds up on the part.
You will. I don't know if you've seen it over the years, but in some of the like scope mounted videos and stuff that I've done, I'll take Loctite and I'll drop it on one screw, like a big blob, and then I'll use that screw to coat all the other screws. And I'll just literally transfer it over, and it's a lot easier to do it that way than it is to try to get a teeny tiny amount out of the bottle. And
That, or what you could do is take the Loctite that's in that bottle and put it in a little tiny needle oiler that gives you you don't have to squeeze very hard. It's a needle oiler, and it just gives you a very tiny, precise amount. That would probably be one way to make that Loctite go further without wasting it.
I also will put a drop on the table sometimes and just dip the screws in it.
I've done that before.
but-
I like putting it on the screw and then using it to coat the other screws. I've done that before.
But a little goes a long way. Use the right Loctite or thread locking compound for the intended purpose. And like if it's already got Loctite on it or some kind of thread locker, or anti-vibration compound, whatever from the factory, you don't need to add any more. Okay?
What if you just really don't want it to move?
Don't do it. Don't do it. Proper torque is listed for a reason.
There
Use
is
it.
the skinny on your thread locking compounds. I hope you enjoyed today's video. We went a little bit far down the nerd rabbit hole, and I learned some things. Maybe you learned some stuff too, so it's always fun. Have yourselves a great day. Many more videos on the way. And let's go ahead and let's just give a brief moment of silence for Chad's hair. Bum, bum, bum. All right. Have a good day, y'all. See you next time. Bye-bye.